Hello and welcome to the course on C Programming Learn to Code series. This is the 36th lecture of Unit 2, and in this lecture we will discuss a new concept that is called your type conversion. So let us first understand what we mean by type conversion and how to use type conversion while you are writing an expression in C programming language. So let's begin. So generally what happen, suppose you are writing an expression in your C programming language. What happen over there, you are combining the data or different type of data may be present in your we can say in your expression. There may be different type of data may be associated with it. Okay, for example, if you see this one, in this particular program, so there are two variables I have declared over here in the first line, that is your int x is equal to 25 and y is equal to 30. Then I have declared another variable which is of float type. Okay, so you can notice clearly in this third line that it is written z is equal to x plus y. That means in this particular expression there are two type of data gets involved. That means we want to add two integer value, that is the value of x and the value of y, and I want to store it in z. Z is nothing but z is a float variable. So while I am assigning the integer data to a float variable, there comes the concept of type conversion. That means one data type need to be converted to other data type, because we know that whenever we want to add 25 and 30, which is previously integer, we get an integer value. That means 30 plus 25 is 55 we will get, right? So whenever you get 55 and you want to assign this 55 to a float variable that is shown as z over here, then what should be the output of this line, that is the printf line. So in printf line I want to print the value of z with the help of format specifier percentage %f. Now what should the output you will get over here? You will get the output something like this, 55.00. There will be 60 due to your percentage %f symbol over here, means the float data type, the precision is 6. So you get the answer as 55.000000. Okay, this is the output you will get. That means here the compiler automatically converts this integer number, that is 55, to a float variable. So this actually called the type conversion. This concept is actually called the type conversion. That's why I have written in the above program, some type conversion is made by the compiler. That is, the integer to float conversion occurs over here, and this is called the concept of type conversion, or sometimes it is called type casting. Okay, so I hope you understand what do you mean by type casting. The type casting concept comes into picture whenever you combine the different data type and you write it in a single expression. That time this type conversion concept comes into picture. Well, so how the type conversion will be achieved through C programming language, that we need to understand. Means whether compiler is always converting the data type from one data type to another data type, or is there any other way. That means, is there any facility provided by your C programming language so that we can convert one data type to other data type? That we need to understand. So for that, C programming language provides two type of typecasting concept. One is called implicit typecasting, and the second one is called your explicit typecasting. So what do you mean by implicit typecasting and what do you mean by explicit typecasting, that we will explain in the following slides. So let's begin with the discussion of implicit typecasting. So what exactly implicit typecasting is? When the compiler automatically convert, so remember the term, automatically converts any intermediate values to the proper type so that the expression can be evaluated without losing any significance. So in the previous example you have already seen this, where the conversion has already been done from an integer value to a float variable without losing any significance over there, and it is automatically converted. The user has not specified any, or he has not given any instruction to the compiler to convert that 55 to 55.000000. But compiler, when he saw that an integer is actually assigned to a float, he just convert it into float automatically. So that in that case, the concept is called implicit type conversion. To elaborate it more, let us take another example over here. So here you can see I have taken a variable, that is in the first line I have taken a variable that is z, which is of float type, and I have assigned a value that is 2.65. Then again I took another variable whose name is x, and it stores integer variable. And in third line we want to assign the value of z to x. So the same thing I am doing over here, but in a different manner, means we are using in a different program over here, but the concept is same that we have discussed in the first slide itself. So what I am trying to assign, I am trying to assign a float variable, or the value of a float variable to an integer variable. In the first slide we just tried to assign a integer data to a float variable, but here just the opposite we are doing. So that means whenever I want to assign 2.65, which is a real number and it needs a floating point variable to be stored, but I am trying to assign it to x over here. So what is x over here? X is a integer variable. So when we want to assign a float number or a real number to an integer variable, then the compiler automatically converts this float value to its corresponding integer. So what exactly the compiler will do? The compiler will discard that, let's say the in this question it is given 2.65. So the compiler will discard this 0.65 value from the given number. Okay, only 2 gets assigned to this x. That means after executing this printf statement, the output produced by this program will be only 2, not 2.65. 2.65 will not be displayed, because as this is a real number and I am assigning this real number to an integer variable, so this real value or the float value is automatically converted to integer variable. Okay, similarly let us take another example over here. So you can see here I have declared a character variable z in the first line, and I have assigned a in that character variable. In the second line I have again declared a variable of integer type, and in the third line I am trying to assign this character variable's value to a integer variable. So what happened in this particular case? We know that whenever a character is stored inside the memory, it is stored in the form of its ASCII value. And again we know that we have already discussed the ASCII value of capital A is 65. So exactly Z contains what? So if it is Z, then Z contains 65 in it. Now even if it is 65, when you want to print it, it will be printed in the form of capital A. Anyway, whatever the value may be. So but in this third line what I am doing, I am trying to assign the value of Z, which is A in program, but in memory it is 65. So 65 gets allotted into X. Okay, so that's why when I want to print the value using the printf statement, then automatically this 65 will be assigned to X, and X will contain also the same value, that is 65, because ASCII value of A is 65. That's why that A values means the variable, that is the character A whose ASCII value is 65, that 65 gets assigned to X. That means it is a implicit conversion. So what it will print you? It will print you 65. So this particular line will print 65. Okay, you can check it with any compiler and you can check that the answer will be 65. Okay, so this is how the implicit type conversion occurs in your C programming language. I am creating a table over here to show you whenever there are two operand of different data type, what should be the result when automatic type conversion will be applied. Automatic means implicit type conversion will be applied. So you can see here, when operand 1 becomes integer and operand 2 becomes character, and you perform any operation using these two operand, then the result will be automatically converted into integer. Similarly, I am just taking another example from here. Let's say the first operand will be float and the second operand will be long int. Then when you perform any operation between these two operands, then the result will be a float. Got it? So this table specifies all the different type of basic data types, and whenever both the operands are different and what should be the result, that is already shown. So the result field is showing over here, and these are the operand 1 and operand 2. Similarly, for this operand and operand 2, this is the result column showing over here. So you can see and you can able to understand whenever you are using different type of data in your expression, why that data showing some result of integer or float or character, why it is showing. So that's all for your discussion of implicit type conversion. Now, is there any possibility, means is there any way available so that we can explicitly define the compiler that try to convert this data to this particular data? Yes, that is also possible, and that concept is called your explicit typecasting. That means many times there may arise a situation where we want to force a type conversion in a way that is different from automatic conversion. So whenever user want to convert one particular data type to other data type, then he can explicitly specify something in some syntax we will follow, so that the data type will be converted into that particular data type that we are specifying. Okay, so the syntax of writing that will be data type, then you have to write the expression. So first you have to write the data type within the bracket, don't forget to give this bracket. Then you need to type the expression over here, so that whenever the expression will be evaluation is finished, the evaluation of this expression will be finished, the result which is produced by this expression will be converted into this data type which is specified by you, and that value will be assigned to some variable. Maybe you might have written as variable, let's say c is equal to this. Then whatever result you get from here, that will be converted into some type that you have mentioned over here, and that result will be assigned to c. Okay, so you need to follow this syntax while you are trying to use your explicit typecasting. So let us take example for that. So the first example I have taken over here from the first example that I have taken in the implicit typecasting itself. So you can see here I have written float z is equal to 2.35. This is a float variable and I am assigning a float number, that is 2.35. And in the next line what I have written int x, and I am trying to assign z to x, but I want to perform this explicit typecasting. Okay, that's why what I have done is I have used this bracket and type int over here. That means I need to convert it into, because I have already taken x as integer over here, as I have taken x as integer and I want to assign a integer value to this x, that's why I just write over here int inside the bracket to specify whatever expression that will be present after this int will be converted into integer, and that value will be assigned to x. Okay, so for my case the expression is 2.35. now 2.35, if it is converted into integer, then it will be 2, and that 2 will be assigned to x. Okay, hence in this particular example we will get the output as 2. Similarly, if you take this example, here also I am trying to assign the integer value of this z. So z contains what? Z contains a character whose ASCII value is 65. That means the integer value of this a is 65, and that 65 is assigned to x in this particular line. And finally, in printf statement, what will happen? The output will be result equal to 65. Okay, so this is how the explicit type conversion works. So whenever you want to use explicit type conversion, then you need to follow this syntax, and implicit type conversion you don't need to worry about that because the compiler automatically doing it. So that's all for the today's class. Thanks for listening. Goodbye.